Anybody that is listening out there in podcast land, I am Demetrios Brinkmann, and I am with David, aka David.
Yes.
And just so everybody knows, this is a new series that we've got going on. We are going to be doing coffee break sessions, talking about doing deep dives into certain topics. And David's going to be teaching me about these different topics. So if anyone has a topic you want us to drill into, feel free to reach out. Or if you feel like you know a lot about a certain topic, go ahead and let us know that you want to be on here and you want to teach us.
Yes.
David, it might be good to start with a little bit about yourself. Give us a bit of an intro.
Yeah, for sure. So my name is David, as you guys know. I'm a machine learning engineer, and I currently work at a company called Benevolent AI. And I love to code. I love to meet with people. I love to build stuff. And one of my passions is also just communicating the things that I love. So I think this is a perfect opportunity for us to get to chop it up and learn some things together.
Nice. And so if anybody is wondering what that sound is in the background, we figured out how to share music while we're talking. So while we're getting down with this, I mean, we've got today, what we're going to be jumping into is serving models on Kubeflow.
Serving models.
Serve it up. We love serving.
Yeah. Now, on the subject of serving, last night on the channel, I shared this article, a really good article about this I forget her name, but this author that basically walks through her experience of trying to deploy a model in some sort of production fashion. And, you know, she walks through her idea process, like how she actually came up with the idea, which is pretty cool. Like some of them was like to basically create like this, I remember the second one was like a natural language processing app, and wanted to make it available over an HTTP endpoint. So she walks through how difficult it was, man. Like how like, you know, you see like these tutorials, they look super easy. You're like, oh, I got this, bro. And then you start and you're like, oh shit, what happened? Like, you know, this went down south real quick.
If you want to do anything that is not in that tutorial, if you want to like personalize it or customize it in any way, then all of a sudden things hit the fan, right?
Yeah.
So anybody that was wondering, her name was Vicky Boykis.
Shout out to Vicky Boykis.
Yeah, it's a great article. We'll put it in the links below, or if you're listening on podcast, then it'll be in the show notes. So she talks, I loved it because she just really showed how difficult it is to deploy, and it goes along with what we wanted to talk about today and serving models. And we are going to specifically dive into serving models on Kubeflow and how you've been doing that. Can you give us a background of like what you've been using Kubeflow, how you've been using it and all that?
Yeah, so I've been using Kubeflow to serve my models through live endpoints, and that's one way to serve a model. And so maybe we should even slow down a little bit and talk about what does it mean to serve a model or to deploy a model into production, right? So a high-level overview from my man Demetrios is that basically it means it's the process of taking some sort of trained machine learning model and making its predictions available to its users. So whoever the end users are of this application, if it's available to them when they need it in a way that they need it, that's serving those predictions. And so typically that's what we mean by serving those models or deploying that model.
All right, that's perfect. Now, with Kubeflow, you've got a lot of different ways to serve the model, right? Like there's Kubeflow serving, there's TensorFlow serving, Selden serving. What are the differences between those, and why would you choose one or the other? That's what
That's a good question. So, and I was actually confused by that myself. So it's rather than saying what's the differences between them, let's say what Kubeflow is and how it kind of answers that question. So Kubeflow is actually an abstraction on top of these serving frameworks like TensorFlow serving or XGBoost or Onyx, Scikit-learn. So it's a layer on top of these serving frameworks that will allow you to basically create jobs that are optimized for these frameworks. So instead of, let's say, just TF serving, those jobs are optimized for TensorFlow models. While another framework, I haven't actually tried it out with another framework, but maybe it might work, maybe it won't. But Kubeflow is made to generalize across.
Wait. Maybe it might work and maybe it won't.
I mean, who knows? No, I'm not. I haven't tried it yet. You never know, because like for example, the format in which a TensorFlow save model, like the way that you have to actually submit a model is different from these other ones, but there are some similarities. Like, for example, if it's a pickled object, maybe that works. I haven't tried it. That's all I'm saying.
Yeah.
But yeah, to answer your question,
of the doubt.
yeah, it's an abstraction on top of these serving frameworks, and so just that alone makes it more general. So you don't have to just stick to TensorFlow. You could use PyTorch. You could use even your own custom model, which is how I'm using it at my company. Mm-hmm. And yeah, so it's a flexible framework that allows you to create these serverless applications.
Okay, and so like TensorFlow serving is there, and basically Kubeflow goes on top of it, so you can serve via Kubeflow, but really you're serving, if you're using a TensorFlow model, you're really serving via TensorFlow serving.
Yeah, so like there's like, if you look at, there's a couple of different ways to do it. So we're going to actually walk through today a demo of what it's like using the Python SDK, the software development kit, and how that's one way to deploy a model. But yeah, there's other ways like using Seldon, or I guess the more typical way in Kubernetes is using something called a YAML file or a manifest. And so like you just specify the framework, the type of job, and if you have a TensorFlow model, you can specify that. And then in the backend, it's using TensorFlow serving. But I haven't interacted it with directly, to be honest, just through the Kubeflow layer. So yeah.
Okay, nice. Yeah, and what is Knative serving?
Oh yeah, good question.
Mean?
Yeah, so it's like the whole Kubeflow stack that actually makes it what it is. So Knative serving is, as far as I understand it, it just allows you to create these custom resource definitions, which are objects that extend this Kubernetes API. And when I say like the Kubernetes API, I mean like a pod or a job or a service. These are objects that Kubernetes has defined through the API that you're allowed to use to do certain things, right? So Knative allows you to do that, but to create more custom resources. And they do that so you can deploy these serverless containers. And maybe we should step back and say, what is this? What is serverless? What is a container? So first, what's a container? Container means I like to think about it as like a little box where all your code lives, and it has everything it needs to live in and survive in that box. And what I see it is that a Docker image, which is what builds that container, is going to take like a snapshot of the operating system, the software that you need to actually run that code. So that's a container. And then serverless is the best way I like to think about it is that it's not on all the time. It's going to be turned on by some event. So it's going to be an event-driven trigger, so to speak. And that's cool because it can turn on and auto scale to increase to meet the traffic. If there's a lot of traffic going on, it can scale back down. So it's cost effective in that sense that you don't have to have a server on at all times, although you could do that. So it's just, it's configured around this idea of events. So it only, when you hit that API, then it starts doing what it does and churning out predictions, but it won't be on at all times. And that's just one approach to serving these models, because serverless comes with its own sort of issues, I think. For example, like you don't have as much control over the server itself and some of these things, but you could actually do that. There's ways to work around that.
Interesting. So now I've heard words like what is it, Istio being thrown around?
Yeah.
What?
Yeah.
That's below Kubeflow, right?
Yeah. So So the way I see it, and maybe let me just look up this picture. I love this picture. So you have your cluster, right? Let's say your company has an on-premise cluster or an AWS cluster. On top, you have Kubernetes to orchestrate your cluster, orchestrate the containers on your cluster. Then you have Istio, which creates the service mesh. And what that does is it allows your microservices, all these little services that you're creating, to talk to each other. So it takes care of things like load balancing and routing, which can be a pain if you're doing it, on your own. So they provide that. And then Knative is a layer on top to create custom resources that are serverless. And so all of that together, and then you have KFServing allows you to create these, to serve models, to create like, I guess to serve these models through serverless applications. And it's quite nice. And we're going to show you how to actually do that today.
Yeah, perfect. But before we get there, slow your roll a little bit, because
got you.
Native serving serves up to Kubeflow, and then Kubeflow
it's underneath it.
So
underneath Kubeflow, it's like part of what they used to build it.
Okay, and so then when you serve with Knative, what are you serving? Because it's not models, right? It's
under
models.
No, so like it could be any other service. It could be like an app, a web app, maybe that you're trying to deploy. So the Knative layer is not specific for machine learning. It's just for serverless applications and containers. So it just allows you to then, if you are serving models, to make that component serverless. Does that make sense?
Yeah.
And for anyone that's listening, if I'm botching this, please correct us and let us know.
Yeah, come on here and dispute our claims.
Yes.
So,
but
yeah, give me some use cases for this. Like, not Knative, but Kubeflow serving. Like,
so for
that you're doing.
There's a lot of things that you could do at Kubeflow, but let's say for, one common case of online prediction or real-time prediction, right? You want to make your model available to end users in real time, meaning there's information that they input that is actually required to make those predictions, and you can't really do this in advance. So that other model of serving predictions by, let's say, training the model offline, serving those or storing those predictions in a database, and then when you need them, pulling them out. You can't really do that for some of these applications. I think a classic one is like Netflix. The user inputs certain things in real time, or you could think of other applications that require decisions to be made at the time of when the user's actually there. And another reason for using this, like the serverless aspect, is if you don't actually need to stand it up all the time. Let's say maybe you're serving this function in real time, but you only need to hit it maybe like, I don't know, a few times a week, or maybe 10 times a week. And that's actually for my use case what it's like. We want them to be in real time, but it's not going to be on all the time. It doesn't need to be on all the time. And so there's no need to have a service running that whole time. It's just, it costs money to do that. So if you're trying to save a little bit of money, that's one smart way to do that. Plus, it's also nice, like if things start getting crazier, like let's say for some reason the users use it a lot more, then it can scale up for you. And it then when that goes back down, it scales back down. So you have that freedom of kind of just having something that's a little bit more robust than what you would maybe have to make yourself. Although you could, if you know what the environment is going to be like pretty well, then you may have a better, it's nice to have that control and do it your own way. But if you just want something out of the box that I think doesn't need to be on all the time, but you need it to serve real-time predictions, then I think Kubeflow serving is one really good way to go.
Yeah, and so going back to that blog article that we referenced earlier from Vicky, I think. The blog. And so Vicky was having a hard time when she was trying to serve, right? She was running into problems because she wanted to serve models, and obviously we need to get into a bit of like Kubeflow and how it's really easy to serve with Kubeflow once Kubeflow infrastructure is there.
Yep.
I guess 100%. Is how I understand it. And so it works, but if you don't know how to put Kubeflow infrastructure in place, then you have to choose some other kind of way of serving. And so what she ended up using, I think, I'll figure it. She used Streamlit, I think is what she said.
Yeah, I haven't heard of that, but I guess it's some model deployment platform or some of sorts, right? But yeah, like you hit the nail on the head. It's really about the infrastructure in place that makes that actually easy. So Kubeflow is not, from what I've experienced and I've heard from my friends in the machine learning infrastructure team at my company, that there's just always, things that come up, so installing Istio and all of these things that you need to have on the cluster so that you can easily use Kubeflow. It can come up with some, it can have its challenges. But then there's also that other element where if you're serving your model kind of like as a microservice, then there's a few things that make it more easy, I guess, to use it as a microservice. And again, it's like this infrastructure. So there's this really cool, I don't know if you guys have heard of Martin Fowler, but he has his blog post or his blog. I think and he has a company called ThoughtWorks or something like that. And he has a great series on microservices and what some of the prerequisites to have a microservices architecture. And I think that's actually related to this because sometimes, serving it, through a live endpoint is just too much. There's too much work that's required to do that. Maybe you're better off just putting it in a database and pulling it when you need it, especially if it doesn't need to be done in real time or if you could do this in an offline matter. So yeah, it just becomes tricky, to have all of these things in place. And if you're just working on your own, trying some tutorial, you haven't thought about all that stuff that's happening to get that set up. And I've done this. I've been like, oh man, I don't have this installed. And let me try to do that. And you go off on like one small bug turns into like a 3-hour tangent where you're like, what am I doing?
Yeah. So I think that's a perfect segue into when you show us how KFServing works and how once it's installed, once you have Kubeflow up and running, what are you doing to serve?
Yeah, so I set up a little demo. I'm going to...
And I think while you're sharing your screen and all that good stuff, there is something that you told me, was it yesterday or a few days ago, about how you needed to still learn a lot of stuff when it came to, we lost the music.
That's all good.
It's all good. We don't need it anymore.
We don't.
We need to get serious. There's no more chit chat.
Yes.
Some code.
Yes. But you were saying that there was some learning that was required to like kind of to serve models. You were saying, I'm sorry, I missed that part.
Yeah, exactly. Yeah, you were telling me that like even though it's pretty straightforward as far as serving models on Kubeflow goes, you still had to learn a bunch of crap. So maybe to help people out that are there and looking to serve models, you can tell us what it was that you had to go and learn about when you wanted to start serving models on Kubeflow.
For sure. So I think a fundamental tool is Kubernetes. It's so essential to everything that's happening because that's what's actually going to be that's how you're going to interact with your cluster. And so, for example, whenever I'm running a job of sorts, I'm trying to do something like, say, train a model or run batch inference or serve a model, I need to run that on the cluster, and I'm going to run that on some sort of Kubernetes resource. So let's say, for example, I have a training job. You could run it as a job, a Kubernetes job. And so you have to have at least a decent understanding of how the Kubernetes API works, how to use kubectl from the command line, because when you deploy something, you should be able to go into the logs of your pod to see what the heck is going on. And so like just being able to navigate your cluster and know what to look for. Another fundamental technology is just containers. So Docker, being able to build Docker files that containerize your applications that are not like super clunky, being able to, I think like those two are like the basics, I think, for being able to do a lot of this stuff. Yeah, those are foundational. Then like on top of that, like Kubeflow uses these concepts. So then when you want to kind of dig a little deeper, you're going to run into that. But then there's also things like APIs, like what does that mean? An application programming interface, and how do you make a good like interface between what you have and what your users are actually going to be using. And that's like a really, it can require a lot of thought and really understanding your user stories. And so like, there's a lot of engineering concepts that I think come to the front. Like there was a slide about what you need to know to like use Kubeflow. And they talked about like you need to understand gRPC, REST, you need to understand serverless, like all these little things that come up. And I will say that you can get away without knowing a lot of this stuff and get up and running, because I personally did not. And when I first started working as an engineer, I didn't always know all these things. But if you have the ability to quickly learn and Google and be resourceful, that goes a long way. But eventually you're going to have to kind of get some of these concepts down to be able to deal with them,
because you said in there, you were like, oh, well, you want to be able to go and look into the logs. What are some times when you need that, when these skills come in handy, right?
Yes.
Models breaking, or when...
That's one. Let's say for something simple, let's say you ran out of memory. So for example, part of let's say a step of the model to serve it is to actually create features for it. And, let's say you're making a call to some other API in your company and the payload is large. Let's say it's just a really big piece of data. And then all of a sudden if you're not doing it in a serverless fashion, you are actually standing up that service, then you run out of memory, you get a signal 9, your process gets killed. And the error just says your process was killed. It doesn't really tell you what happened, why it happened. For those of you who know, I guess, your operating systems well, maybe you're like, okay, maybe that smells like an out of memory issue. But it's those type of things that you need to be able to investigate it, to kind of narrow down where the problem is. And that's always a very good thing. It's it's not this, it's not that. Okay, so if it's not these two things, it's probably that. And so that's one common case. I need to be able to look at the spec of the pod, to see, or if I want to do kubectl describe, I want to see what's going on inside. What happened? Did it start okay? Did it exit for some reason? And you'll be able to see a lot of this stuff by using Kubernetes. Kubernetes provides from the command line a lot of cool tools to just quickly look at the logs of a container, to describe a pod, stuff like that.
And when you were learning about this, did you follow any specific blog or anything you want to?
I used everything. So I would not, for people listening out there, I'm a obsessive learner and that's just how I've always had to learn. I've always been the kid that I'll study 20 hours and get an A-. Someone will put in 2 hours and get an A+, but it's just how I learn. I have to work really hard. So for me, the short answer is everything. I mean, there are some resources that we can link that I think are cool. There's actually some, Katacoda is this cool website that allows you to actually do tutorials where you're actually doing some of this stuff. Use Helm, which is also a very important technology. Use Kubernetes, kubectl. There's a lot of cool resources out there, but to be honest, the real experience came from just messing up, trying something and failing miserably, and then learning from those mistakes. So, but yeah.
All right. So walk us through what you got here.
Yeah, let's do it. So, all right. So keep in mind, guys, for all you engineers, don't be nitpicky. I just do this together. It's going to work though. But here I have some 3 steps that I think you guys could go and clone this repo and reproduce. We're going to link the URL later. But for example, if you say, let's say I have a data scientist, my company, and he has some cool set of data that he wants to model. He has this great idea. He's framed it well. It's meeting the needs of the business. And he's like, all right, I'm going to go and train this model. So I have here a script to train a single model. And let me walk you through what some of the steps are. So I'm just using here the Iris data set, which comes with sklearn. It's about flower petals. So it gives you some features about the flowers, and then you're trying to predict the category. I think there's 4 categories if I recall correctly. So the first step is let's load that data. Then we're going to do a train test split. This is not actually necessary for this. It's just something that I just do by habit. Then we have a function to actually train that model. I'm using a random forest, but you could use any model you want. Then I'm going to save the model. I'm going to pickle it or just serialize it. And what I do is I wrap it in a main function to just put that all together as a script. And so going back to the scenario, I have a data scientist that has some model. He's going to train that model. And so we're going to walk through what that does. I also set up a make file that will allow you to easily do this. So if you go into the make file and run make train, it should start training your model. Let me make, okay, cool. So you can see here that the training score is perfect. And the test score is
less from you.
So, whatever, let's not get to the details of this, but let's say they've done this a bunch of times. They have some metrics at the end of these training runs, and based off all of these runs, they find the one that they like the most, right? They're like, oh, this one had the best metrics on our benchmark. it's looking like it's good. Let's serve this one, right? And so then what I would do right after you have this trained model, so what I've done is I've saved it in this outputs folder. You can see here's the serialized model. It's in a pickle format. Now I want to serve it, right? Now there's a bunch of different ways you could do it, but we're going to walk through what it's like with KFServing.
Mm-hmm. Now the fun part.
Yeah. So, oops. Can you guys see this okay? Is it too big? Is this okay?
No, it's perfect.
Okay, great. So yeah, here I have a class, right? I called it the model service class. And what I'm doing is I'm inheriting from this KFServing KF model class, okay? And this is one way to create your own custom model, right? And so for example, let's say this is here just an sklearn model, but let's say if it was something different, like, I don't know, my company created its own, like, a semi-supervised model that like does something, right? And it doesn't really fit one framework. Maybe it's done in like some archaic language or something. And I still need to serve it. So there's a couple ways you could do this. So here in this use case, I'm doing everything locally. So I have that model available in the same environment. But in most cases, in the way that we do it at work is we have a model registry where after a training job, we submit it. And what they can do is when we pass them over this script, they can actually inject into it from, let's say, an S3 bucket, the model that I registered, right, at a certain point in time. And so I'm kind of skipping some of those things. But in this case, I have it locally in this outputs folder. So here I'm choosing the name for it, right? But the reason why I have it like this is if you are sending this to like your model deployment platform, they could actually put inside of this a model from some sort of S3 bucket. So I don't actually have to have anything locally. The reason why I'm not doing that here is I don't want to have to worry about getting S3 access. I have it to my job, but I don't want to go through all that. But the idea is that if you wanted to, this would be better off if you were actually having this trained artifact inside of like some S3 bucket that would then be loaded into this whenever you need it. So let's walk through some of the basic components. So you're going to first overwrite this load method, all right? And what this load method does is it loads whatever training artifacts you have. So in this case, this is just a trained model. So I created this helper function in the util section, just called load model. And the reason why I added this is just like some template code. Let's say this was an S3 path. Here is where one good place to actually download that model, save it to a local path, and then load that into the KF server. Oops.
Oh, nice.
All right. So that's the first thing you have to do. You have to overwrite the loading method. And this is going to be done when the server is started. So let's say, remember this idea of serverless. It's not on right now. A user makes a request, server goes on. Usually it should be done with low latency. It's going to load that serialized model and it's ready to go, right? That's when the server is turned on. So now when the user hits it, it's then going to make predictions. And one thing that I found, there was just some bugs that I encountered, but it's good to set the status of the service to ready underneath this load method. And then what's going to happen is when the user actually makes a request, they're going to pass in a request object. It's going to be in the form of a JSON object. Here's what it looks like. So for example, this is following the TensorFlow REST API format. And I'm using it in the row order. So here, this is one row. Here are the features. I just have like literally 2 rows of data. Actually, no, yeah, 3 rows of data. And each one is a feature for this model. So this is like the format that it would have to be in. And this is just for for passing it to that server. And what you'll typically do is you'll take that request object. If you just need to like literally just pull out some things, what I'm doing is pulling out the instances object, turning it into an array. If for some reason something goes wrong, I'm raising a key error just so I can kind of know what's going on. And then Tornado, which is the web framework underneath KFServing, allows you to have these custom error messages, which are really nice because it's really important to know like what's going on if some sort of exception comes up, to be specific. And then what I do is I already loaded my model. I pass in those inputs that the user just put in, convert it to a list, and that's it. I output the predictions. And here's what the main function looks like. I called it serve just because Sounded better. But here's my model service. I'm passing in my model name. I'm passing in some model artifact. Remember that this probably could be on S3, but you have to configure all of this to have S3 access. But that's typically a better way to do it. You're not going to be getting a model locally, right? You're going to be serving some model that has already been trained and is elsewhere. I'm loading all those trained artifacts. It doesn't have to be just a model here, by the way. Let's say there's other things that you need at inference time as well that were part of the training. Here would be a good place to do it. You could also, and I didn't do it here, but let's say, for example, I needed to do some pre-processing. What KFServer recommends is you overwrite a pre-processing method. And if you want to do some post-processing, you overwrite some post-processing method. And we don't have any need to pre or post-process. But if you needed to, let's say if you have like an image model, right, some sort of computer vision model, maybe you need to convert it to a certain format, and that would be a nice place to do it. And then you want to output it in some sort of, nicer way. So that would be the way to do that. But let's recap real quick. What you do is you're going to inherit from this class. This is the Python SDK. I'm going to build on top of that, and I'm going to overwrite certain methods that KFServing has told me to overwrite. In this case, all I need to do to have a minimum model is the load method, so I could load the whatever training artifact I want to serve, and a predict method that takes in a request object, parses it, passes it to the model, and then returns the predictions as a dictionary. This is all because it has to be in JSON format. Is that so far so good? Any questions there?
No, this is awesome. Yeah, I like it. And
great. So you mentioned before other tech, right? So I have it here set up so that if you wanted to, you could actually run this inside of a Docker file. So I created a Docker file. You don't really need to do this, but I say that this is probably better. It's always a better option to containerize it because that just makes it easier to move around and other people to navigate it, right? So here's an example where, again, it's super easy and there's probably more efficient ways to do it. I'm just using the Python as the base image, copying over the requirements, installing them, copying this repo, moving them over to the root directory. And then I have this entry point. But one good idea, by the way, is that you try to reuse your Docker images in some way. So using this command, you can actually overwrite this at runtime. So you could use a different entry point. So here I have the KF server, but maybe I wanted this to be train.py. Right? Maybe I want to run that training job in the same container. You could do that. And that's probably, in my opinion, I think one of the best ways to use it, because if you could have a Docker container for like every little piece of code, but then it's kind of nice when you reuse them. In my company, what we like to do is we like to create base images that have pretty much what, let's say, for example, everything that we have here, and then build a specific maybe KFServing container that uses whatever I built from this as the base. And then now it has all of the requirements already. So now when I build that new container, I don't have to reinstall everything. It already has it inside of that base layer. And so that's one nice way to use it. But what I was saying before is about changing the entry points. You can use one Docker image and just overwrite or change what you're going to run inside of that container. So here, using the command argument, you can actually do that. If I wanted to have, let's say I knew that I only wanted one entry point, then I could use the entry point argument. And this just means that you can't, this is always going to run no matter what. And there's a couple different ways you could do run, which means you could run it one time, but oops. I set this up just to show this is kind of what it would look like, but you actually don't need this to run this locally. So going back to what I did in my makefile, I kind of walk through, and by the way, what a makefile, I love makefiles. It allows you to template what you're doing. But here, if you want, you could train the model running that make train entry point. If you wanted to run it in a Docker container, what it's going to do is it's going to build that Docker file. It's going to tag it with just a name. Here, I think I named it inference service. I'm going to run that container, expose it from port 8080 or port 8080 over here. And then I'm going to, inside of this container, I'm going to run that KF server. And so what that's going to do is it's going to make it it's going to run it locally. And then in another terminal, I could hit that endpoint and get predictions. But we're actually going to do everything locally. So sorry if I'm all over the place, but what I'm going to do is I'm running this serve. Okay. So let's walk through what that looks like. So again, I'm at the root of my directory. I have a trained model. It's available. What I'm going to do is I'm going to run make serve. It's going to start it up. So look what's going on.
The suspense is killing me.
It registers the model. It's now listening on port 8080. It's by default, it uses 0 workers, and it started up 8 processes, right? So now my model is a service. I could hit it. A user could go and make predictions. So why don't we do that?
So it's out there live.
Yeah, it's live, right? Well, locally right now, but yeah. So here I'm going to use a curl, right? So I think what this stands for is the client for URL, or client URL client. But yeah, it allows you to interact with some sort of endpoint. So here I'm going to post to the endpoint, and I'm going to post inside of it this JSON input that I was showing you before, or sorry, this input JSON. I'm going to post this. All right. So again, this is typical REST API terminology. You could get something, you could post something, but in this case, I'm just going to make a post request, right? So here, the content type is JSON, and just for convenience, I'm going to output the results of this to another JSON file called predictions.json. So are we ready? You ready to run this bad boy? So in another terminal, I want you to write make request. Boom. Oh, what happened? So it says we got some bugs. Oh, that's why, because I wrote you see what I did? I left those pre-processed methods open.
Oh, yeah.
Yeah, I don't need that. So let's remove that. Boom. Let's do this again. So let's restart the server. A nice thing about this is that it fails fast, which is always a good thing. Okay, cool. So I started it up again. It's running locally. Let's make another request. Boom. Okay, got a 200 response. It worked. Let's take a look at the predictions. Boom. Okay, so it says for that... it says that the first row was of class 2. So let's say the prediction, it belongs to this flower group. The next row belongs to this other flower group. And so these are the labels at the end of that. And there you go. That's how KFServer basically works. You create, right? You create this model service object, right? Which basically what it sounds like, it's turning your model into a service. And it's going to run using a KFServer object, all right, which under the hood, I believe, uses the Tornado HTTP server, I believe. So if you want to go and tinker, you can go do that as well, maybe increase the timeout time or whatever. And like I said, if you have more complicated things that you need to do, like pre-processing, like let's say I want to scale the inputs, or maybe I want to one-hot encode them if I had categorical features. You could do that in that pre-processing method. And then if I have stuff that I want to do after I make predictions, like let's say I don't want it in this format, I want it to actually say the name, then maybe in the post-processing method, you could do that. But here, let's try it again. I'm going to make another request. Boom, another 200. Boom. Cool. See how fast it is? It's about, I mean, obviously it's a super small model with like only a few examples of data, but this is typically what it looks like. Now, in a real production environment, what this will look like is from another service, we're going to basically create the endpoint, which what will it do is when I create an endpoint, I'm going to say, use this model. So I'm going to point it to a model ID, use this image path, this Docker container that this is going to run in, point me to an S3 path where this trained model artifact is. And under the hood, it's going to use, let's say if I Dockerize this KFServer script and make it available, I'm going to tell them, or I'm not going to tell them, I'm going to give them basically this containerized code. And whenever I want to deploy it and create that endpoint, it's going to run this entry point. It's going to run this KFServer script. And what that's going to do is it's going to stand up a server. And that's going to be on whenever the user makes predictions. And it's going to auto scale when more traffic comes up. It's going to scale back down when the traffic goes down and things are slow. But this is it. I mean, it looks probably super simple, but I was working on this
yourself.
Yeah, wait till you try it yourself. But for those of you who are watching, and by the way, again, just give me some grace. I just put this together. But the typical flow is going to look something like this. And just so I remember how I mentioned before, running this in a Docker container, you could do that as well. You could run the make build command. It's going to look exactly the same thing, but I'm just going to I'm going to tag it with a specific version, right? Let's say this is my random forest model, version 1. It's going to install the requirements. Okay, so I built it. Where's my make file? I need more monitors, man. Like that's the one thing I miss from working at home is that I just don't have
Where are all my monitors?
Yeah, where are all my monitors? Okay, so what happened here? I wrote make build and make I know what I did wrong. So it's rebuilding the model.
What did you
as always? I think because I changed this. So all this is doing is it's building it. But I see what I did. So here, do this. So build, make, make run. Dude, see what I'm saying, man? Like, this is like my life. Like, there's always something small and I just miss it. Like, it's just, this is me. But yeah, so here I built the, yes, honestly, that's actually a very important thing, attention to detail. So we're having some import errors. What did I do here? From utils, where am I importing the utils? So I'm using this load function. Why doesn't it like it? Okay, well, I don't want to spend too much time debugging, but yeah, it's just an import error. But yeah, if you guys want to reproduce this, you can see this in the GitHub repo. I'm sure this is, let's say, for example, maybe, where am I right now? Let's see if this, I doubt this is going to work because this is all running in a container. But yeah, it should work. You should be able to run it locally just using this make serve entry point. Okay. That should be good to go. Yeah, I added this last minute. This is what I get for adding stuff last minute. But yeah, you guys get the point. Serving, it's pretty straightforward. But again, like we mentioned before, if you don't have like Kubeflow installed in your cluster, then this, while it works locally, there's still a lot of other things that need to be involved to actually use this in a production environment. But the gist is there.
Yeah, the overall understanding. I can see that. So now our idea is to do more of these deep dives into different stuff. I really appreciate you teaching me about Kubeflow serving and showing me how it would work. We're going to be trying to do these weekly as our little coffee break, coffee versus tea, because I'm a big tea guy. You're a big coffee guy.
I'm the coffee guy.
And so if there are any other kind of ideas that you would like us to go over, feel free to suggest. We're going to link everything that we talked about into the show notes below if you want to check those out. And I think that's about it. If there's anything else you want to say, David?
Yeah, I think this is like a great opportunity for the both of us to like learn, man. So yeah, let's try to make this about the things that we care about. So the more that you guys put in your input, let us know what you guys care about. We have a better sense of what to talk about. And guys, by no means I am no expert. I can tinker, I could do things. But it's very much a learning process for me. So this is also a cool excuse for me to kind of see how well I know some of these things and articulate them to you.
Yeah.
So, exactly. Bear with me, guys.
Yeah. And like we said, if you want to jump in here, there's space for more
sure.
people.
Yeah. We could pair on something, debate some concepts. I know there's like there's definitely a lot of, it's healthy to debate like best practices or tools or ways of doing things. Like, for example, what I was describing for containerizing it and what's the best way to deploy it as a microservice or some other ways. But yeah, this should be fun. I'm hoping that you guys enjoy these. Because I did that was fun doing that. How about you, Demetrios? Now, so for you, let's do a real quick recap. Uh-oh. Yeah, what did you learn, Matt? Uh-oh. Yeah, this is quiz time, man. You got me on the spot, live coding, stumbling all over the place. I had a bug come up. What's up? What did you learn?
I just pretended like I was following up. I have no idea what you were talking about, to be honest. No, I mean,
the gist, though.
Yeah, exactly. What I really understood from this with the serving is that you're not going to be able to serve with Kubeflow serving if you don't have Kubeflow stood up already. So the infrastructure part of Kubeflow is probably 90% of the battle, it seems like. So getting Kubeflow up and running in your environment is a big test, and that's a lot of work up front, so that the data scientists or whoever's working with these models can then reap these benefits of being able to serve the models. And so what I understand serving models to be, and you can correct me if I'm wrong here, but basically you have your model, you say, all right, I'm ready to make this go live. You want to deploy it out into an endpoint, an API that can get hit by some user, an end user, right? It's where the end user says something like, let's take that, I'm on Amazon and I'm shopping for face masks because that's what I do these days. And Amazon says, oh man, this guy's looked at 3 different face masks. I'm sure they're going to probably like these other face masks, right? But what's happening in the background there with that recommender system is that Amazon is taking all this data of mine and it's live, and it's saying to this endpoint, hey, we need to make a prediction.
Yeah, so that's one way. Like an endpoint is typically when you're exposing the model through an API, right? So like and when I say like an endpoint, it's like a resource that the API offers. But that's like the programmatic way to do this. What I think in this example, that would typically be hidden from the user. So they're not going to hit like an endpoint. Yeah. They're just going to be, using the application.
These recommendations.
Yeah, exactly. They're going to, there's going to be some model.
Something is taking that data and it's hitting an endpoint, and then it's bringing back different recommendations, and then it's being transmitted through the UI, so that me as a user, I just see a bunch of different face masks come up. Yeah, pretty much. So, and with these sorts of applications, low latency is typically really important, right? Because you don't want a user can go pretty fast clicking on stuff, and we have to be able to learn from those in real time. So this is where another layer of complexity comes in, where maybe Python is too slow, too bulky for whatever reason. Maybe we need to rewrite it in C++, something more low level to make this even quicker. And I actually even saw that there was this cool library out there that allows you to transform, let's say, a scikit-learn model into a PyTorch model. So it's running in tensors, it might be a little bit faster as well. So there's all sorts of things you may need to do to make it faster. But yes, exactly what you said. Yeah, under the hood, there's a lot of stuff typically going on. And this is for, machine learning applications. Not everything uses machine learning. Yeah, completely. That's a whole different topic we can jump into. But as far as the Kubeflow serving, when we got into what serving is and serverless, that was another eye opener for me. Serverless is just something that is dormant until it needs to be turned on.
Yeah, and that's why I say it's like serverless. Yeah, it's like there's still a server, obviously, but it's like it's not on at all times, right? And that's
it needs to work.
Yeah, it's chilling. Yeah, it's taking a break, and it's cost effective too.
Yeah. So, but it does. I'm glad that you pointed out that it does have its downfalls too. So it might not always be the best.
Yeah, sometimes you need it standing up all the time, maybe. And I imagine for something like, let's say, like Amazon, that's typically what the case is. Maybe for some things, maybe some endpoints that are not hit as often, maybe they have them serverless. But yeah, that's typically what it's like, man.
Cool. Well, this has been awesome.
Yeah, this has been so much fun, man.
I like that you walked me through it. I'm really appreciative, and we'll see each other again next week, I guess, for some more story time, and you can teach me some more coding.
Yeah, we'll do something else. So let's see after we release this, what you guys think are some of the next things we should tackle. But yeah, guys, this is really fun.
Join us in the Slack community, that we can continue to learn together. I think this is a space that is changing so fast. We all have our own ways of doing it. And I put this in the it was from Vicky's blog post, or what did I call it? Her blog article. Just how, what she said was so perfect. It's like each deployment process has, thousands of different ways that you can deploy, right? Because it can be, you're using scikit-learn, you're using TensorFlow, you're pickling objects, you're serializing them, you're going on to AWS Lambda, or like you can be using C# or you're using Kubernetes, whatever it is.
Yeah.
There's so
many
different
complicated
ways. There's so many different ways that you can be doing this. So for us, this Kubeflow serving is one way that we can do it. We can jump into other ways if we want later on down the line, but that's what we got.
Yeah.
This is it. So take care.
Hope you guys liked it, man. Take care, guys.
See ya, everybody.